You are watching the news, then suddenly you see a news report about liquefied petroleum gas or LPG canisters exploding even if it's empty. Have you ever wondered why this happens? Keep on watching to know the explanation.
So why do LPG tanks explode, even those that are empty? To be clear, the LPG tank doesn't explode by itself, but because of the gas that's inside of it and other external factors. It's actually not an easy task to trigger propane tanks to explode, unless they already have defects, like a leakage, or are under a high temperature environment.
When the temperature of an LPG gas increases, the pressure of that same LPG gas increases as well. The increase in temperature results to the molecules of the gas to strike the container with more force at a rapid motion, making the pressure of the gas to increase as well. This temperature-pressure relationship was discovered by Joseph Gay-Lussac, a French chemist. His law states that the pressure of a given mass varies directly with the absolute temperature of the gas when the volume is kept constant. The equation for Gay-Lussac's law is pressure over temperature equals the constant, or pressure 1 divided by temperature 1 is equals to pressure 2 divided by temperature 2. This explains the reason as to why LPG gas tanks explode even if they are empty.
More so because empty tanks still contain air inside them when they are empty.
Last night, an LPG container resides in the backyard of Jenny at 54 degrees Celsius with a vapor pressure of 1,794 kilopascals and was used by her family for cooking dinner. The next day, having the LPG container empty and being exposed to a higher amount of heat due to sunlight, its temperature increased to 207 degrees Celsius, which caused it to explode and start a fire. What was the pressure of the LPG container that caused it to explode even though it was empty?
The temperature will now be converted to Kelvin in order to solve for the pressure. Since the formula for Gay-Lussac's is P sub 1 over T sub 1 is equals to P sub 2 over T sub 2, we can now substitute the given values to the formula. With this, we get 1,794 kilopascals over 327 Kelvin is equals to P sub 2 over 480 K. We can now cross-multiply these values and divide both sides by 480 Kelvin to get an answer of 2,633.39 kilopascals. The reason why the tank exploded is because the pressure built up on the inside became too high for the tank to handle.